cycle. For today's class, we're going to continue with the same. Let me just open the course outline that you see how we're going. In case there are new students joining us, they'll be able to see what we are doing. But of course, I can't see new students today. So what I've opened the course outline, your course outline. This is a DICT, and we began by looking at oh my.
I can't see the course outline.
Just a minute. There are some network issues. So can you see it now? Can you see it? Network.
Not yet.
Not yet, eh?
Yes.
So just give us just give me a minute. We see whether it's going to work. Okay, but I remember last week I sent you the course outline, eh? And if you can access it, it's okay. From the previous lesson, eh? Last week, eh? I sent you the course outline for the DICT. Can you guys still hear me? Hello, can you still hear me? Okay, it's okay if you can hear me. So what we did in the previous lesson, we looked at the program development and design, that is the program development life cycle. And we looked at the 7 steps, which we usually have in program development. And I hope that you guys can still remember. So for today, we're going to start with what we call the program structured programming concepts. And then after that, I'm going to introduce you to program design tools. So let me try and share my screen again. We see that it's possible. Now, just a minute. Can you see my screen, Mr. Abdi? Can you see my PowerPoint presentation?
Yes.
Oh, that's good. All right. So now we're going to start by introducing ourselves to what structured programming is all about. Of course, this is also in the first topic, the very first topic. So structured programming is concerned with structures used in a computer program. Generally, structures of computer program comprise of decisions, sequence, and loops. So when you talk about decisions, this is when, for example, a program has to make a decision based on a given condition. Like, for example, if a condition is true, if a given condition that you have said is true, then some statements are executed. If the condition, otherwise, if the condition is wrong, is not true, let's say, then there are some other statements that will be that will be executed. That is what we call the decision structure. The program makes decisions on behalf of the user. Like, let's for example, you create a game that allows only people who are over 18 years. So this one you have to use a decision structure where, for example, somebody enters the age. If age is less than 18 years, then maybe this person would be told you're not allowed to enter. The condition is if somebody is greater than 18 years, they can enter. If they are not allowed to enter. So for that one, you're going to use a decision structure. Then also we have another structure that we use in instruction programming, which is called the sequence structure. This is where program statements execute sequentially, one after the other. So that is called the sequential structures. In this one, you don't use any decisions. You don't use any conditions. So the program will just execute one statement. After that statement is over, another one begins to execute. Then after that one, you also group structure. And in this one is, for example, if you want to do a repetitive task, like for example, if you have a class of 20 people and you want to capture their marks, you don't have to like write a program that will actually, like you say printf enter marks, another time you printf enter marks. You just need to use something we call the loop structure, where a certain statement like enter marks will repeat like 20 times for you to capture the marks of those students. So that is called the loop structure, and is also used in the structured programming. So structured programming forces a logical structure in a program to be written in an efficient and understandable manner. Now let's look at another subtopic here. It's called the program design concept. And in this program design concept, we usually have several types of program design concept. One is called, when you talk about program design concept, these are approaches that you use when you are designing a program. Okay, so we have one which is called the top-down approach. And in the top-down approach, this is where you begin by creating a program. You first of all, like, you consider the whole program as a whole, and then after some time you go breaking down that program until you get to the very minor detail of that specific program. So like, for example, you can create a program. Before you create a program, you can have an idea of what that program will do, and then from there you zero in, what do I need for this program to do what I really need. So that's where now you begin from the top, what the program will do, and then now you go breaking down into the very small units or small modules that will enable you to accomplish that that goal that you have. Yeah. So that's what we call the top-down approach. A top-down approach is essentially the breaking down of a system to gain insight into the subsystem that make it up. Like, for example, we also have a computer. A computer is a system in that it has different components that work together to achieve a certain objective. So when you talk about the computer system now, you want to break it down. What are now the subsystems that are inside the computer system? We have the input devices, we have the output devices. So from there, you want to know what input devices are in this computer system. You find that there are things like the keyboard, we have the mouse. Then after that, when you want to know what are the keys that are in the input, that are in the keyboard, you have different types of keys in the keyboard. Then after that, when you want to know what are the keys, what are the buttons that are on a mouse for it to be an input device. So you began by considering the computer as a whole, and then you go zero in it. You go breaking it down to the very smallest details for you to gain an understanding of how a computer system is built. And that's what we call the top-down approach. Then also, like, for example, here we have an example. When you have a large farm, and then you break it down into smaller departments and sub-teams. Like, for example, we can consider like Safaricom. When you see Safaricom as an organization, you just think it's Safaricom. That's a top-down approach. You just consider as Safaricom. But inside Safaricom, there are many departments, including there are branches, which are in different parts of the country, and of course, different parts of the world. And of course, when you break down those small departments, you find there are sub-teams inside that organization. That is an example of a top-down approach. Then also, you can also consider the example I've given you, the computer system, which is made up of small subsystems. So you began by considering the computer as a whole, and then you zero in or you break it down into small subsystems. That is the top-down. Let's look at the benefits of top-down approach when you are designing a program. One of the benefits is that breaking a program down into small parts makes it far easier to understand, solve, and manage. So that is much easier. When you break a program down into small subsystem, it becomes much easier for you to understand. Like, for example, if I say a computer system, and then I break it is divided into input devices. It's also divided into output devices. So now from there, you are likely to understand better of what a computer system is all about. Then top-down, number two, top-down design allows several programmers or teams to work on the same project without getting in each other's way. And that is very true. The next one is each module of code to be tested. Each module of code can be tested separately. Okay, those are the benefits. Those are the benefits of top-down approach. Then also we have disadvantages of this method, top-down approach. Of course, one of it is that top-down programming complicates testing. Of course, when you began by considering the whole system as a whole, testing can also be an issue. And if you want to look at testing, you can go back to the program development lifecycle. We talked about that testing, the different types of testing. Then also generates modules that are very specific to the application that is being written, thus not very reusable. And then, of course, the last one is all decisions are made from start of the project, depend directly or indirectly on high-level specification of the application. So those are the disadvantages. Like every time, it's very complex to understand. First of all, you have to understand everything else. Like if you say a program can do A, B, C, D, and then from there you now zero it down to some small subsystems. At times it can get very complex. So that approach can get very complex as you proceed. Just a minute. Okay, class, just give me some 2 minutes. I want to confirm something. Now I hope that you can still see my screen here. Is it visible? Abdi, is my screen visible? Unmute yourself, Abdi. Abdi, Ali Abdi Ahsan.
Yes.
Can you see my PowerPoint presentation?
Yes.
Okay, that's okay. So those are the disadvantages of what we call the top-down approach. Of course, after that one, we also have another one, which is the opposite of top-down, which is called the bottom-up design. And this one is, first of all, you identify the most primitive operations. So we are saying any design method in which the most primitive operations are specified first and then combined later into progressive larger units until the whole problem can be solved. It's the opposite of top-down. For example, a communication program might be built by first writing a routine to fetch a single byte from the communication port and working up from that. So this one, you begin from the most basic unit, and then after that one, you proceed to the other units as you complete your project or your program. So advantages of this bottom-up design is that it is appropriate for applications where bottom-up design methodology is used. So that's a benefit. Another one, test conditions can be created easily. So this one is opposite to top-down in that you can do testing. Testing is much easier. Testing is much easier because when you start with the most basic unit, it's likely before you go to the next unit, you have tested that unit thoroughly. Then number 3, if the low-level modules and their combined functions are often invoked by other modules, then it is more useful to test them first so that meaningful, effective integration of other modules can be done. So this one, every time you create a module, like a small module, you can test it effectively before maybe you combine it to another module. And that is a very effective way. That's what I'm saying. Even testing is easier with the bottom-up approach. Also, always starting at the bottom of the hierarchy, again, means that the critical modules are generally built and tested first, and therefore any errors or mistakes in these forms of modules are identified earlier in the process. So in case of so this one you're able to detect errors quickly or in earlier stages of program development. Then another number 5, advantageous if major flaws occur towards the bottom of the program. So this one is much easier. Of course, when you identify the program at the beginning, that program you correct it before proceeding to the next. That one will be it will be much advantageous than you identify the program once the program has you identify a problem once the program has completed, or once you've completed designing. That's when you're identifying a problem. So it's much advantageous in that you are able to identify errors in a much earlier. Then another disadvantages of bottom up is that test engineers cannot observe system level function from a partly integrated system. They cannot observe the system level functions until the top level test driver is in place. So that test engineers cannot observe system level function from a partly integrated system. They cannot observe the system level functions until the top level test driver is in place. So this one simply means that those people who are building this system cannot really understand what this system will finally accomplish until the very final module has been integrated into that system. So that's a major disadvantage, because you have to wait until the last module has been integrated in the system for it to accomplish what it is supposed to do. Then another disadvantage in number 2 is that the program as an entity does not exist until the last module is added. So that simply means you cannot really say you have a program until you have the last module integrated with other modules. Then number 3, bottom-up approach. In this, so we are saying one big disadvantage of bottom-up strategy is that in this sort of testing, no working module can be presented as far as several modules have been built. So as long as you have, like, let's say you are building a robot, and let's say, for example, for this robot to work, you have to place maybe let's say it's a human robot, like the ones we see in the movies. For this module to work, you have to like power it, not even power it. You have to place the head. You have to integrate the head for it to be able to do its functions. And it's until you place or you integrate that head, the head of the robot, for that robot to function. So that's a major disadvantage in the bottom up. Then number 4, this approach is driven by existing infrastructure instead of the business processes. Okay, let's go to the modular design. There's another type of program design. We use this one. Whenever you hear of this modular design, it simply means you're going to subdivide the system into modules. So when you talk about modular design, is an approach, design theory and practice that subdivides a system into smaller parts called modules or skills. So when you subdivide a system into some small modules, that's what we call modular. This is mostly used by people who are developing things like when people are doing big projects. Like, for example, if you're designing a program like the Facebook website, that Facebook website has been developed by many programmers from different parts of the world. So what they usually do, you find there are certain people from Japan who are working on a certain module. There are other people from the USA who are working on a certain module. Other people from the UK who are working at a certain module. And then at the end of it, they combine those modules together to have what we call Facebook. Even today, that's what they do. There are people who are in charge of some specific module for Facebook, let's say. I'm just using it as an example. So you find those people are in UK, maybe. Others are in Japan. So once they do that, once they finish, they integrate those modules together. Okay, let's continue. Advantages. One is readable programs. When you use modules, you are able to create readable programs. Modular programs help develop programs that are much easier to read since they can be enabled as user-defined functions. So when you use what we call modules, you can use something we call functions. And as we continue in the course, I'll be introducing you to the concept of user-defined functions. Then, of course, when you use modules, programming errors are easy to detect. Okay, so it's much easier for you to detect errors when you break it down into small modules. Also, another one allows reuse of codes. When you are using modules, you can actually reuse a certain code. What does that mean? It simply means once you create a module, you don't need to create another module that does it. If a certain module is doing something and you want that same module to do another function, you don't have to like create it afresh. You just need to call that module using a code, and then that you don't have to write it from scratch again. You can reuse that same module to do maybe another function or the same function in the same program. So that is one of the major benefits of modules. It allows reuse of codes. Another one is improves manageability. So this one, like I've said, having a program broken down, program broken into smaller sub-programs allows for easier management. And this is true even in real life. When you are doing, for example, even when you're doing revision, and then you say, I'm going to start from a certain unit, I'm going to focus today, I'm going to focus on this topic, I'm going to do it thoroughly, this revision, and then tomorrow I'm going to do another. That one is much easier, unlike when you as a student, you say, I'm going to cover the whole of structured programming in one day. Okay, so when you use modules, even in study, when you are studying, you say, today I'm going to do from this point, I'm going to start at this topic up to this subtopic, and then like the way you are doing currently, we're not going to cover everything in this class. We're just going to cover some small bits, and that one is much easier even for me and also for you guys on the other side. Also, another advantage of this one is collaboration. With modular programming, programmers can collaborate and work on the same application. So you find designing a program also becomes simpler because small teams can focus on individual parts of the same code. So this is, like I was saying, when you're designing a program like Facebook, you find there are people from different geographical regions collaborating on that website, and that is much easier, especially when you are designing large projects or large programs. Okay, so those are the advantages of modular design. Then also we have disadvantages. One is that can lead to problems with variable names. We'll be looking at these variables. What are variables? And as we continue. So you realize that when you have different modules, there could be some variable names that somebody else used in another module that are similar to your variable names. So that one can lead to some conflict in some way. Also, another disadvantage of module design is that documentation of modules must be thorough. Of course, you know what documentation is. We talked about that one in the last session, so you can revisit that session. Also, another one can lead to problems when modules are linked because link must be thoroughly tested. So this one, when like, for example, there's a team working on a certain module here in Kenya, another team working on another module in Uganda. So when for those two modules to be combined together, those modules have to be thoroughly tested. Otherwise, if they are not, this program is likely to cause a lot of problems in the future, or they may fail to integrate together. So those are some of the disadvantages of module or modular, of what we're calling modular design. Now, let's go to another one. Another approach, design approach that we use is called monolithic application. It is a software application in which all modules of programs are combined into a single module. So whenever you hear of mono, that word mono simply means one. So when you have, you are working on, you combine different modules together into one program, that is called a monolithic application. But I want you to note something, class. I want you to know that the major approaches of program design concepts are three. We have the top-down approach, then also we have the bottom-up, and then also we have the modular design. Those are the major ones even in NEC. But for these ones, I just found them as I was doing my own research, and I found that there are others like this one, monolithic application, where different modules are combined into a single program. A monolithic application is self-contained and independent from other computing applications. So this one is when you combine different modules into one single program. And that's what we call monolithic application. And then also we have another one, which is another approach which we call control flow structures. And of course, this one, I really don't want to talk about it much because it will conflict with something that I will be teaching in the future. So it is order of function calls, instructions, and statements when a program is running. The term flow control details the direction the program takes which way program code. So this one is actually the use of, so this one is not really clear. I was actually supposed to remove this one from the list. The control flow structure is not supposed to be part of this design, these approaches that we are looking at currently, the program design concepts. So this one, actually, I'm going to get rid of it. Please, just a minute. I get rid of it as of now. Yeah. So that is, so we usually have the major one. I've said we have the top down, we have the bottom up, and modular design. Those are the approaches that we have in programming. Yeah. So now we are done with that. Let's go to the very. I hope that you can see my screen. I'm sharing your course outline. Let me ask one of you to confirm whether they can be able. Cynthia, can you see my course outline?
Yes, I can see.
Okay, that's good. So we are done with the structured programming concept. That is what I was looking at. We said there are three, the major ones. Now I want to introduce you to what we call program design tools. This is where we look at things like flowcharts, pseudocode, algorithm. Yeah, so let's look at that. So here we have program design tools. In the previous class, I remember I started with the physical class in town campus. We looked at, we began with algorithm. And of course, but for now, we're going to start with pseudocode. And pseudocode, when you hear of that pseudo, some people say pseudo, others say pseudo. So when pseudocode is basically something that is not real, is not a real code, but is something that looks like a code. Pseudo is something that is not really real. Okay. Pseudocode is one of the tools that can be used to write a preliminary plan that can be developed into a computer program. So when you talk about these program design tools, including flowchart, pseudocode, algorithm, their main purpose is to help people with no programming skills to understand. Like, for example, let's talk about people like managers. Some of them have not done programming, and maybe you want to help them understand what your program is doing. So what you do, you create some, you create like a plan or an explanation of what the program is doing using these program design tools. And this pseudocode is a generic way of describing an algorithm without use of any specific programming language syntax. So we usually don't have, you're not going to write it like you write a program, that is a description of how a program works using some English statements. So when you say, the name suggests pseudocode, it cannot be executed on real computer. So if, for example, you are given a pseudocode, that pseudocode, when you enter it, for example, you write it on maybe code blocks, that one cannot run. It's actually going to generate a lot of syntax errors simply because it's not written in the same level as the same level of accuracy as you do with a program. So it's a pseudo, something that resembles a real program, a real programming code, but it's not really real. Okay, so we say pseudocode by nature exists in various forms, although most borrow syntax from popular programming languages like C. We also have another one called Lisp and another one called Fortran. Okay, natural language is used whenever details are important or distracting. Okay, so let's continue. So when you're writing pseudocode, you can use what we call control structures or logical structures. So we look at, we usually have three types of control structures. We have one which is called sequence, another one is called selection, and another one is called looping. So you can write a pseudocode either using the three control structures. And in our case, we're going to start with writing pseudocode using the sequence structure. When you talk about sequence structure, we say this is a structure. This structure is the most elementary structure, or is it the most easiest structure for any programmer to understand. The sequence structure is a case where the steps in an algorithm are constructed in such a way that no condition step is required. The sequence structure is the logical equivalent of a straight line, for example. So we're going to look at an example. But before we do that, I'll explain what sequence structure is. So when you talk about sequence, is when you write programs that do not require any condition. So what you have a program that is executing one statement after the other sequentially without any, like for example, you can have a program that is accepting two numbers. Then after it accepts two numbers, it earns the two numbers. After it earns the two numbers, it displays the answer. So that's a sequence structure. No condition has been used in that structure. And let's look at an example here. Suppose you are required to design an algorithm for finding the average of 6 numbers, and the sum of the numbers is given. So this one, we're going to write a pseudocode that will accept how many numbers? That will accept 6 numbers, and then it will find the average of the 6 numbers and also the sum of the same. So these are pseudocode. Pseudocode, some books will say that we instead of saying starting a pseudocode using start, some will suggest that we use begin, and that's a problem. We don't have a standardized way of writing these pseudocode. That's why they give us, that's a disadvantage actually. They don't have a standard way of writing. So the pseudocode for this will be as follows. So we're going to start pseudocode. We usually start them with start, like here we began with start, and then of course some people would prefer to first of all enter numbers, like enter 6 numbers. They can actually start here. After start, they will say enter 6 numbers. Okay, that's also, let me just show you. Some people will just come here and say enter 6 numbers. 6 numbers. So once you've entered the 6 numbers, then you say get the sum of course of these numbers, of the 6 numbers that you've entered. Then after that, after you find the sum, find the average, which is sum of the sum you got from here, divide by 6. And then of course after that one, I'll put the average. And then at the end of it, for the pseudocode, you have to say stop. So we begin with start and then we end with stop. Some books will say we start with begin instead of now start. You come and say begin. Of course, that's another way. But for us, let's just use start for now. And also, so at the end of a pseudocode, you write stop. Okay. Now, if you are to represent this same program using an algorithm, using a flowchart, it's going to look as follows. It's going to appear as follows. Of course, you guys have not done, some of you have not done flowchart, some of you have. And of course, you can see, we'll look at it in the next lesson, the different symbols that are there in flowchart. And of course, here, we're going to start. Also, for the flowcharts, we use the word start. And then the input symbol. This one is wrong. For me, this program is wrong. We're actually supposed to use the input symbol. So let me just show you what I mean. This one is wrong. This pseudocode is wrong, actually. If I can be able to earn just a minute. Because you cannot say get sum with an input symbol. So this one is supposed to be, instead of this symbol, you're supposed to say enter numbers. Enter numbers. Then after that one, you are going to use this symbol to get the sum instead of this one, the one that we have used here. So I'll be talking about that one later. So this pseudocode is actually not correct. If you are the one who, if it was an exam, then somebody will have actually said this is not correct. So let me just put an X there just to show that it is not correct. Yeah, so this is not correct. Simply because of that, because for us to get the sum, we don't use this symbol. When you're doing calculations, there's a certain symbol we use. The guys who have done pseudocode, the guys who have done this topic, they know what I mean by that. Yeah, so that is actually incorrect. So let's just go to the next example of a pseudocode. Example 2. This is a pseudocode required to input 3 numbers from keyboard and output the result. So this is another example of a sequence pseudocode using this sequence structure, and you're going to enter how many numbers? 3 numbers using the keyboard. And then after you enter, of course, this is not complete. You're supposed to find the sum. So here we can say enter this pseudocode required to input 3 numbers from the keyboard, and then after that one, find the sum. Find sum, and then comma output the result. So for this one, we're going to say start program, and then use variables. Of course, you can say this one is trying to describe a program actually that was written by somebody, because the guys who have done this topic, you understand, you're going to declare variables instead of declaring them, say int sum num1, num2, num3 of type integer. So this one is describing a real program written in C. Like you can be given a program in C, and then you're told convert this program into an equivalent pseudocode. And this is what this gentleman here was trying to do. So for us, I can actually get rid of that. We say start program, and then we say accept number 1, number 2, number 3. So we are inputting, actually input number 1, number 2, number 3. Then after you input, you find the sum of the 3 numbers. So you say sum is equal to number 1 plus number 2 plus number 3. And then after you've done all that, you find the sum, you're going to display the sum or output the sum of the 3 numbers. So you're going to say print sum, and at the end of it, you're going to say end program. So that's another way of writing pseudocode. I hope you're understanding. Now, for me to see whether you have understood what I'm saying, do this exercise. I don't know how I'm going to get it, but you can write it in the comment section, in the chat section, and then you post. I see whether you have understood. So this is what you're going to do. You're going to So you're going to write a pseudocode which will accept 2 numbers from the keyboard and calculate the sum and product, displaying the answer on the monitor screen. So write a pseudocode that is on the chat section. You're going to write this pseudocode, and then you press enter. Once you're done, you post. I will see it. I will see whether we are in the same page. So everybody do that. I want to see whether we understand the concept of pseudocode. So write a pseudocode which will accept 2 numbers from the keyboard and calculate the sum and product, displaying the answers. Actually, it's the answers. So you're going to display sum, and also you're also going to display the product on the monitor screen. So let's do that. Okay, so we have guys who are still trying to propose. So we are writing a pseudocode that will accept two numbers from the keyboard and calculate the sum and product, displaying the answer on the screen. Let me see whether there's anybody who has done it. Okay, let me see. Okay, we have several people who have done it. We have the first one, who is Esther Kangu. So start program, accept numbers 1 and 2. Are they two numbers? Yes. Sum. When you print the sum, that is product. That is correct, Esther. Then we go to somebody else here called Cynthia Maloa. So Cynthia Paola. So start program, accept num1, num2. Sum is equals to num1 plus num2. That is correct. Product is equals to print sum. That is correct. Stop. Is it stop? Have I used stop? Okay, let's confirm. Is it add program? So you have used stop, Paola. Don't know whether that is correct, but it's okay also. All right. Then also we have Joseph Kinodian Joroge. Start program, accept numbers, accept numbers. Hey, Okay. This one is number 1, number 2, sum number 1, number 2, product number 1 times number 2. Okay, so that one is correct, Joseph. Then we have IV Wambui who say start program. That is not correct, but maybe you just posted it when you pressing the enter, the go next, ikajipost your comment, ikajipost, which is understandable. Then we have Janet Wangari Njoroge, that program. Then accept number 1, number 2. That is correct. Sum is equals to num1 plus num2. That is correct. Sum of number 1 plus num2. No, product you don't say product is equals to sum of number. No, it's supposed to be num1 times or multiplication num2. Then of course at the end you're going to display the sum. You're going to say print sum and print product. So that one, there's a problem somewhere here. There's a problem. Then we go to Ali Abdikarik Hassan, says start program. Of course, that is, I know what has happened there. So also we have the revamp MP4, somebody called the revamp. So we say start accept num2 sum, that is correct. Product is equals to revamp 2. I will request you to be using your name, your official name, because I'm actually taking your names to show the people who have attended the class. So when I actually print the attendance for this class, your name is not displaying. It's saying the revamp. So when the office asks for your name, they will not be able to know whether you are attending the class or not. And it's important for you to be, for them to know that you are attending the class. So kindly don't use this name, the revamp. They are vamp MP4, so that we can be able to know who is attending the class. Yeah, it's good for. So accept. So start accept num1, num2. That is correct. Sum is equals to num1. That is correct. That is correct. Print sum and product. That is correct. Then we have Ali Tenor. Ali accept num1. Accept num2. That is correct. Sum num1, num2. That is okay. What about the product? Sum yours is not correct. The revamp, and the same. Okay. So that is correct. I can see most of you have done it, but this class I think has more students than those ones. We have a total of how many students? 1, 2, 3, 4. I think 10 guys. So it seems as if there are some guys who have not been able to join us. Some from Paul, Shaun, Gigi. You are from Nakuru, Paul?
Yes, I'm from Nakuru.
Okay, that's good. Okay. Now I've just realized that we've not been recording the session, but I've recorded it. And that was a mistake. We're supposed to record so that at least the guys who you can be able to get this session later on. Yeah, so that is correct.
Oh, yeah.
Okay, that is correct. Most of you have understood the concept. Just go current. So this is the solution. So you are supposed to say start program. And of course, because this gentleman was describing a program, we said use variable sum. Of course, he was declaring. So the first thing is to accept number 1 and number 2. Then after that one, sum is equals to num1 plus num2. Then print the sum. The sum is that. Also product is equals to num1 times num2. And then of course, print the product is product. So this one it was actually describing a real program that was written down by somebody. But as we continue, I'll show you how to write a program, and then from there you'll actually understand what he was trying to do from this example. Okay. Now, pseudocode can also be written using decision. What we were looking at previously was using selection, but pseudocode can also be written using what we call decision structure or selection structures. Like for example, here we have got a flowchart describing a certain procedure that is happening. So we are saying, okay, this one, of course, if you have not done flowchart, it may not make a lot of sense. But let's say, for example, you're entering some numbers, and then you say here, you say enter numbers 1 and 2. Okay, and then you say add the two numbers. Then you say if the number is greater than 18, what will happen? If it's true, if when you add the sum of the two, if the sum of those two numbers is greater than 18, what will you do? What did you do? You're going to do task A. Else, if the sum of those two numbers is not greater than 18, it will do task B. So this is basically a flowchart, but of course I will revisit this one in the next class, the flowchart concept, so that at least you can understand. This is just a description of what usually happens in a flowchart. So you first of all check the condition in a selection structure. You test the condition, and if this condition is true, this task is done. The task A will happen. Otherwise, if you test the condition and the condition is found false, then task A will not be done, but you do task B. Okay? Is for example, if you switch on the lights, when you enter into your room, and then you switch on the lights, and you find that there are no lights, what happens? You have you have to do something else, which is maybe to light up a candle. Okay? That is what you do. If the condition is not true, another task is done. And if you are to write this one using a pseudocode, you're going to say if condition is true, then task A will happen. Else, if the condition is not true here, task B will be done or will be executed. This is using decision structure. Also, you can write a pseudocode using something we call repetition or iteration. Of course, this one will do it in the future. In like another 2 weeks, we'll be revisiting this concept of using repetition or looping. And in the looping, you first of all check the condition. If the condition is true, you do a task and then you repeat again. Like for example, if you want the screen to, you want your program to run from number 1, 2, 3, 4, 5, 6, 7, 8 up to 10, you have to write a condition that if a certain number is less than this, then okay, I will be showing you this one practically. For now, it may not make a lot of sense. But what I want you to understand for now, in a repetition structure, you have a condition. If this condition is true, a certain task is done, and then it is repeated again. If the condition is still true, the task is done again, and it is repeated again. If the condition is still true, the task is done again. So this program will repeat until the program becomes false, or the condition becomes false. So if the condition becomes false, the program would execute. Let's say, for example, you're counting from number 1 up to 10. So the program will run from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then when it gets to 10, because you are saying this program is supposed to run from number 1, 2 up to 10, when it gets to 10, it will terminate because now the condition will be false. But I'll be showing you that practically so that we don't bring a lot of confusion. In the repetition structure, can be implemented using while loop, for loop, and do while loop. So this one, we'll be looking at it in the future. We'll be looking at what we mean by the while loop. When we talk about the while loop, we say this condition loop tests for terminating condition at the beginning of the loop. So this one actually, we first of all start by checking the condition. So if the condition is true, these statements, a statement or block of statements will be executed. And then you check again, the program checks the condition again. If true, this block of statement will be executed. Until this condition is false, that's when these statements will not be executed. And of course, I'll be explaining that one in the future. Like for example, you can be asked in a question, write a pseudocode segment to print out each character typed at a keyboard until character Q is entered. So in this program, we want, this program is going to allow, it's going to ask the user or the one who's using the program to enter numbers A, B, C up to Z. So the program will then display the character. Like for example, if you press A, then the program will display the character you typed is A. If you enter B, the program will say the character you typed is B. If you enter C, the program will display the character you entered is C. Let's say, for example, you accidentally press Q. Then what will happen? The program will terminate or will stop executing or will not display the character you've typed. So for you to write a pseudocode for that, you're going to say start, enter a letter. And then while letter, this one is simply, this one in programming, this two greater than, this is the less than sign, a greater than. This one in programming is not simply means not equal to or not Q, while letter is not Q. But of course, because we are writing a pseudocode, we can actually say it's not Q. So let me show you, let me run it again. So this one we say start, enter letter. While letter is not Q, accept. So first of all, every time you enter a letter, it will check, is this letter Q? If it's not Q, it will accept the letter, and then after that one, it will display the letter. Okay? Yeah. So if you press Q, then the letter will be rejected, and the display the character you typed would not be displayed. So that is an example. As long as you're entering any other letter, this one will be, the program will repeat itself continuously until maybe you enter that Q. Let's continue. Let's look at the advantages of pseudocode as we come to the end of the class. One is that it improves the readability of any approach. So that is true. They are much easier to understand. Pseudocode are very easy to understand. Also another one, it acts as a bridge between the program and the algorithm or flowchart. Let's say, for example, somebody has not been taught or has never attended a class or flowcharts, but then they see a pseudocode. They are likely to understand the pseudocode much easier than the flowchart, and that is actually an advantage. Also, another advantage is that the main goal of pseudocode is to explain what exactly each line of program should do, hence making the code construction phase easier for the programmer. So this one is much easier. It makes the understandability. Is there such a word in English? Understandability. I wonder whether there is such a word. It makes a program much easier to understand when you write a pseudocode for a given program. Then disadvantages of pseudocode is that pseudocode does not provide a visual representation of a logic. So you find that if your program is so big, somebody may not be able to understand. Unlike when you're using something like a flowchart, because it's visual, is a diagram that you've drawn, is much easier to understand, unlike when you use a pseudocode. So that's why we're saying pseudocode does not provide a visual representation of a logic or programming. So another one is that there are no proper format for writing the pseudocode. And here there's a typing error. There are no proper format for writing the pseudocode. So you find that in this one, there is no format. You find there, I gave you a problem, most of you guys, somebody will use a different approach from the other, and still it's the same. So you find there are different formats, but it's solving the same problem, and that is a disadvantage because different people use different approaches when writing pseudocode, and that's actually a major problem. Another one, in pseudocode, there is an extra need to maintain documentation. So you need other documentation. Like once you write a pseudocode, you can also add something like a flowchart to be more clear of what you are doing. Another one is the pseudocode. In pseudocode, there is no proper standard. So every company follows their own standard for writing pseudocode. So you find company A uses this standard, company B uses this standard, and of course that one makes a disadvantage for pseudocode. Like for example, you find some companies, instead of using start, they say begin. Okay, so that's there is no standard in writing pseudocode. So here we have an assignment. Let me see what time it is. Kumbe there is time. I want you to write this one. Using pseudocode, design a short system that helps management in reading student marks passed in this criteria. So 70% and above watakuwa wamepata distinction. 60 to 69, they will get credit. 50 to 59, they have a pass. Less than 50%, they have a fail. So write that assignment down. So in the next class, what you do in the next class, you'll actually upload you'll upload your assignment. You upload using Microsoft Word. You just upload this concept. I want to see whether you have understood. You are writing a pseudocode for this system that will help us to read the marks of the students. So write it down. Okay, so once you are done writing, I want you to write in the chat section done, so that I'll be able to see. Oh, so here is pound gige start. So this is correct. Just a minute. Okay, write this one. Once you are done, just type in the comment section done, so that we call it a class. And then from there, I'll be able to we'll continue on Thursday. We'll have the class on Thursday, I think at 8:30. But I think the session will start at 9. So I want to believe that you're done. Like, actually, I can copy this. Let me copy it and post it in the chat section. I can, just a minute. I want to do something here. Let me show you what we do. Instead of you writing, I'll just leave it somewhere. So just a minute. All right. Dan, can you kindly share the notes? Yeah, I will share those notes in a minute. Let me give you the assignment. Let's stop online class assignments. So I've posted there, and also I'll post the notes for you. Let me just post the notes. Okay, so also you have the notes there for the lesson 2, the assignment and lesson 2. So we have come to the end of the class, not unless there's somebody with a question. Is John in the class today? John from town campus is not in class today. Eh? What about Mark? Mark is also not in class. Mark, you in class?
No, he's not in class.
Okay. All right. So we will meet in the next session. Have a nice day. You can leave and feel. The revamp. Okay, I don't know who is that guy called Revamp. Anybody who has an idea who is this guy, the guy who is calling himself the Revamp? Okay, it's okay if you don't have any. Esther, do you know this guy called the Revamp?
No, I don't.
Okay, I think he's that Mark. That guy called Mark, eh? But I'll talk to him next lesson. Okay, thank you very much. Have a nice week.